section 1.2 on functions. Most of this you guys should be reviewing first of all, so I think we're going to fly through most of this section. I think I divided the section into 2 assignments. So section 1.21 I'm going to give you today. Tomorrow I'm going to give you assignment 1.22. And okay, just a review. A function is a function usually, you guys are using this notation, f of x usually just means y. So if I give you a function f from set A to B, it's a relation that assigns each element in x in the set A to exactly one element in the set B. The set A is the domain or the set of inputs of the function, and the set B contains the range or the set of outputs. And this might sound a little strange right now, but I think once you guys see function notation, it's going to come back to you very, very quickly. All right, so let's move on here. All right, an example of this is if you have the side length of a square. Say you have side length 2, and you are, so these things right here would be what we call our domain or our set of inputs, and we are going to assign them to an output or a range. So for example, you have a side length of a square that's 2. What is going to be the area of that square then? You guys, if the side length of a square is 2, what's the area of the square? 4, because you have a square. Draw a square over here, and if you know the side length is 2, the other side length is 2 also. What's the area of that square then? Well, 2 times 2 is 4, so the area of the square would be 4. So this 2 gets what we call mapped to 4 in our set of outputs, which is also known as our range or outputs. So if you have a side length of a square that is 3, the area of the square is going to be 9 because 3 times 3 is 9. So we have another number set within our function in this example, and it would be the number set 3, which is mapped to 9. If you have a side length of 4, 4 times 4 gets you 16, so the 4 and the 16 would go together. And then you have a side length of 5. 5 times 5 obviously gets you 25. 5 would be your input, 25 would be your output. The input are also called your, notice over here it says they're called your x's. Therefore your outputs are your y values. So if you had to name this function, if you had to write a rule for this function, what would the rule be? F of x equals what? How are you getting your answers? What are you doing to the numbers in the input box to get your outputs? Yes, Marcus. Say it again.
Squaring them.
Squaring them. So your rule here would be f of x is equal to, take your inputs, which we call our x's, and we square them to get our output. So f of x is equal to x squared. If you were to list these things as ordered pairs, you would list them just as it says right here, as ordered pairs. You have 2 and 4 together, because if you take 2 and square it, you get 4. You have 3 and square it, you get 9. Take 4 and square it, you get 16. 5 squared, you get 25. Now, there's an endless number of ordered pairs that we could list here, but if we're just talking about the information that we have in this example, this would be all the ordered pairs that we're talking about. Notice we have some numbers in our outputs, some 1s, and a 1, a 10, and a 20. Those are outputs, but they aren't matched to anything in our inputs, and that's okay. We wouldn't list them as ordered pairs though. I made a note here that on page 16 in your book, there's a blue box that has a bunch of characteristics of a function that might be helpful. So you might want to write that down, refer back to it if you need to when you're working on your assignment. Am I going too fast? Am I going too slow? You guys ready for me to move on?
Good.
I'm good? All right, how can you tell if a function is a function? How can you tell if an equation is really a function? So I have a couple of examples here. The first example that I wrote down, y minus x squared equals 4. Solve for y. So whenever you have a situation, you're trying to figure out whether or not it is a function, you got to solve for y. So when I solve for y here in y minus x squared equals 4, I solve for y by adding x squared to each side. When I add x squared to each side, it leaves me with y equals 4 plus x squared. So, is this a function? Obviously, I have the answer written right here. Yes, it is a function. We got to talk about why is it a function. Well, it is a function if I put in any value in for this x squared, if I put any value in for x, square it, and then add 4 onto it, how many answers am I going to get for y? I'm going to get one answer. If I put a 2 in for x, so I would have 4 plus 2 squared. Well, what is 2 squared? 2 squared is 4. And I add 4 to it. What is 4 plus 4?
8.
It's 8. So I get one answer, right? Is there any way I could get a different answer by putting a 2 into this equation? Is there any way I could get a different answer? This is the only answer I could possibly get. So it's looking like this is a function. I only tried one number. I only tried a 2. Could I try something else? Let's try a negative number. What if I put in 4 plus negative 3? Notice my use of the parentheses around my x value, especially when it's negative. If it's negative, you got to put those parentheses around it. Negative 3 squared is 9. Add 4 to it, you get 13. Is there any way that I could get a different answer for this function, or for this equation? Pardon me? What if I used negative 2? So we have 4 plus negative 2 squared. Negative 2 squared is 4, plus 4 is equal to 8. What if I tried 0? 4 plus 0 squared. 0 squared is 0. 0 plus 4 is 4. Am I ever going to get a different answer? Okay, now did you bring up negative 2 because I have the same answer twice here? My question is, if I put in a specific x value, how many answers will I get out of it? I might get the same answer for 2 different x's, but will I ever get 2 answers for the same x value? And I won't, so therefore this is a function. Do you guys remember the vertical line test from a couple years, was it a couple years ago? Maybe last year? I think it was when you took geometry, so it would have been a couple of years ago. Do you remember the vertical line test? Yes? No. Yes? No?
No.
Let's say you have a graph. I'll draw a quick sketch over here. A parabola. We have a parabola. Is a parabola a function? Well, it's a function if I draw a vertical line through the graph and it only touches in exactly one spot. Regardless of where I draw my lines, will it only ever touch the graph in exactly one spot? Will it only touch in one spot? Yes, it will only touch in one spot. Therefore, yes, this is a function. Let's look at an example now when it's not a function. Copy this down if you haven't already. Negative x plus y squared equals 9. And solve for y. You always have to solve for y because what you're doing is deciding whether or not it is a function. Remember earlier I talked about f of x is equal to y. So whenever you see a y, that's what you need to solve for. You're trying to figure out whether or not it is in fact an f of x. In other words, a function. So in this case, if I solve for y, I add x to each side, leaving you with y squared is equal to 9 plus x, but it's y squared. So do you see why I took the square root? Because it's squared. So to undo something that's squared, you take the square root. So I took the square root of y squared, and then when you take the square root of the other side, this should look kind of familiar to you. For example, let's say you have the square root of 25. Well, if you take the square root of 25, what kind of answers do you get?
5.
You get 5 and you get negative 5. You have two answers. So just like over here, when you take the square root of 9 plus x, you get two answers. You have a positive and a negative square root of 9 plus x. So now, if you put an x value in for 9, how many possible answers could you get out? You could get two answers out. Yeah. So let's try it. Give me a value for x, you guys.
7.
7. Good. Good, good. So let's say we put a 7 in for this x. So y is equal to the positive or negative square root of 9 plus 7. So y is equal to positive, negative. What is 9 plus 7? 16. So you're really taking the square root of 16, but you have to take both the positive and the negative values. So what is the square root of 16?
4.
Positive and negative 4. So we have two answers. We put in the same x value, but we got two answers out of it. It's not a function. Does that make sense? I also wrote, what if you put in an x value of negative 5? We put in an x value of negative 5, we would have 9 plus negative 5, which is 4. Take the square root of 4, get 2, so it's positive and negative 2. All right. Let's move on to function notation. This stuff right here, probably not going to be a huge deal. You guys have done this stuff before. So let's say I give you a function, f of x equals 4 plus x squared. This part right here is called your output, f of x. The whole thing is what we call an equation. And then this value right here, which also shows up over here in our equation, is called the input value. So our inputs always get inserted over here, and then our answer is what we get when we actually calculate it. So let's figure out what is the value of this function when our input value is 3, when x is 3. So all I have to do is look at my rule, 4 plus x squared, my equation, and I replace my x's with whatever our input value is. And in this case, our input is 3. So it's 4 plus 3 squared. Well, 3 squared is 9. You add 4 onto it, you get 13 as an answer. What happens when x is negative 2? X is negative 2, it's 4 plus, notice my use of the parentheses. If it's negative and you're squaring it, you've got to use those parentheses. 4 4 plus negative 2 squared. Well, negative 2 squared is 4. You add 4 to it, you get 8. Probably nothing too difficult so far. What happens though if I don't give you an actual x value? Let's say I give you m instead. Well, treat it like it's a number. Instead of writing f of x, you're going to write f of m. And anywhere you see an x value, you replace it with an m. So we have 4 plus, notice this was my x before, so I replaced it with an m. So it's 4 plus m squared. We don't know what m is, we don't know its value, so you have to leave it as 4 plus m squared. What happens if x is not just x? They're saying try, figure out the value of the function when it's x plus 2. So you rewrite the function, 4 plus, in parentheses, x plus 2 squared. So I had to replace my x from my rule up here. I had to replace it with x plus 2. Still square it. And then I did the math here. So let me talk you through the math quickly. We have our 4. Here's your 4. X plus 2 squared really means x plus 2 times x plus 2. What do? How do you get rid of this x plus 2 times x plus 2? What are you supposed to do to this? You FOIL it. First outside, inside, last. So you're going to go x times x, and then you're going to go x times 2, and then you're going to go 2 times x, and then you're going to go 2 times 2. So first of all, you have your 4. I just brought that down. X times x gets you x squared. X times 2 gets you 2x, but then you have another 2 times x, which gets you another 2x, which gives you a total of 4 x's, and at the end you have 2 times 2, which is 4. How did I go from 4 plus x squared plus 4x plus 4 to x squared plus 4x plus 8? What happened between this step and this step? Yeah, combined like terms. So you've got a 4 here, that has to be combined with the 4 here, giving you an 8. So your final answer would be x squared plus 4x plus 8. Another example. F of x equals x squared plus 3x minus 7. What happens when x is negative 4? If x is negative 4, so you just replace your x value with a negative 4. It's negative, so everywhere you see an x, that has to be squared or cubed or to the 4th power or whatever the case is. You have to make sure you're always using the parentheses. So notice the parentheses around the negative 4. You square it, you add to it 3 times. Again, we replace the other x in our equation with negative 4. Subtract 7 from it. You end up with an answer of negative 3. I gave you another example like I did above, where you're replacing x with a binomial, x minus 1. So find the value of the function when x is x minus 1. So I have x minus 1 squared, and then I had to replace this x in our function rule with x minus 1 again. Does anybody need me to walk them through this part right here, x minus 1 times x minus 1? So I kind of just jumped to the answer. X squared minus 2x plus 1 is what you get once it's all multiplied through. But if you want me to walk you through exactly how I came up with that, I would be happy to do that. Anybody need me to do that? X squared minus 2x plus 1. This 3 is just distributed into the parentheses here, giving me 3x minus 3. You collect like terms. Your x squared, you have a negative 2x and a positive 3x, which together give you 1x. And of course you have a, did I screw up here? Oh, positive 1 minus is this coming back to you guys? Is it coming back to you? Okay, all right. Wow.
It's Monday. It's Friday.
I'm gonna stop for today, and tomorrow we're gonna do more on 1.2, but I'm gonna show you guys something that you've probably never seen before. So this is a good place to stop and refresh our memories on functions. We'll start tomorrow with something new.